In this tutorial video, we're going to cover the extra 2 calibration steps to use the 3D topography module with a Theta optical tensiometer. We start off in sessile drop mode, and in the top left corner we see 2 tabs. The Theta tab is for our contact angle view, and the Topography tab is obviously for the topography module. It's also very important that at this point we set a home position for the XYZ stage by left-clicking this button in the software. Now let's place the topography calibration sample on the sample stage. Let's try to get the center directly underneath our needle tip. We can control the XYZ stage using the software, and we're going to move the disc up and also so that we can see the left edge of it. Once the stage is moving in a direction, you can press the button again to stop it. Now move to the bottom right topography tab, hit calibration, and then XYZ calibration. The standard default values in the fields should generally be used, and then instructions for completing the calibration process are also given in the window. Right now I'm in the recipe tab, and I'm decreasing the speeds for the XYZ stage so that I can get more precise movement. Now we need to bring the left edge of the sample into focus, so we can right-click the left edge of the sample to bring up the focus tool. Again, we want to adjust the fine focus until we can maximize the blue peak. Now we need to adjust the position of the sample to align it with the target crosshairs. The sample stage surface should be aligned with the horizontal axis of the crosshair. The left edge of the sample should be aligned with the vertical axis of the crosshairs. The bevel in the sample can help us figure out where the boundaries are to align with the crosshairs. Sometimes it can be hard to get the right position if you're off by just a little bit, so it helps to move farther away from your target and then get a running start and then stop it. This can take a little bit of trial and error to get right. But once you get the position right, you can left-click the top button in that XYZ calibration window. Now we need to move the sample so that the crosshairs are directly in the center of our topography module camera. Now I'm increasing the speed of the XYZ stage so that it goes faster, and I start moving the XYZ stage to the right so that it moves to the topography module camera. Once the sample gets underneath the topography module, the image under the topography tab will brighten up. Then we can move the XYZ stage up and down to get our sample into focus. Now that the sample is in view, we can stop movement and start bringing the sample into focus, specifically the crosshairs. We know we've reached focus once we see the hazy bars going up and down. Those are actually from the diffraction grating inside the topography module. We can adjust the brightness by adjusting the slider in the bottom right window. Again, we can adjust the XYZ stage speeds so that we can get finer tuning of our focusing and positioning of our sample left and right. Once the sample focusing is done, we need to move the sample so that the blue crosshairs are in the center of our sample. Now there are actually major and minor hash marks on this bullseye, and so we need to use a little bit of trial and error to find the exact center of our calibration sample. This intersection is where the center of our sample is, and now we need to adjust those speed settings of our XYZ stage so that we can very finely position the center of our bullseye with the center of this cross. Once this alignment is complete, we can left-click the bottom box in the XYZ calibration window. And now we've completed the XYZ calibration. Now we go back to the Topography tab in the bottom right, bring up the calibration, and now we're going to switch to the Topography calibration. Once again, instructions pop up telling you what to do, but basically we need to move to an area of the sample which is completely white, without any hash marks present. Leave the value in the field at its default value, and once we've reached a pretty good area without any noticeable defects, we can hit OK. I've actually deactivated the auto brightness feature in the recipe tab, but it actually doesn't do anything for the topography calibration, so don't worry about doing that. Now the computer is controlling the topography calibration, and we're going at 5 times speed just to save some time. When you're doing measurements of your own, your sample's topography will be shown in the middle and right image boxes, which are currently grayed out. If there are any white pixels or areas on those image maps, it means that the topography module was not able to resolve the height at those pixels. Sometimes if your sample is extremely rough at those positions, that can cause the camera to not be able to resolve them. Other times it can be because the topography calibration didn't quite work. And so if you see a lot of your samples, when you're taking these measurements, have those white spots, consider redoing just the topography part of the calibration. And now the topography calibration is complete. I would recommend repeating the calibration for the topography module about once a month, or any time you move the instrument. Hopefully this answers any questions you might have about calibrating the topography module for the Theta. But if you have any other questions, please don't hesitate to contact us at Violin Scientific.